Hello, thank you for the time and opportunity to speak with you today. My name is Paul Imbrock. I represent the Indiana Soybean Alliance, and today I'd like to talk to you about PoreShield, a new type of concrete durability enhancer. I'll also refer to this as soy methyl ester polystyrene at various points throughout the time I'm speaking. That was the name used, the scientific name in research and literature throughout the inception of this technology. Since then, the Indiana Soybean Alliance has used the name PoreShield as a way purely for industry education and market awareness to help spread the word on this type of a technology. It's much easier for you to remember, hopefully, and pass along to your colleagues if you can refer to it as PoreShield rather than soy methyl ester polystyrene, which can be a bit of a mouthful. So, as I said, I'm representing the Indiana Soybean Alliance. Indiana Soybean Alliance is a nonprofit trade organization serving the soybean farmers in the state of Indiana. When farmers take their beans to market for the first time and sell them, a small percentage of that revenue goes to the checkoff organizations, the state level being the Indiana Soybean Alliance and the federal level being the United Soybean Board. Both organizations have been instrumental in helping the research behind this technology and then also its industry and market acceptance. The original research behind this was done at Purdue University with Dr. Jason Weiss as the principal investigator. It was done in conjunction with the Indiana Department of Transportation through the Joint Transportation Research Program and Project SPR 3523. The Indiana Soybean Alliance also co-sponsored this work. The goal here was to provide the Indiana Department of Transportation with a more durable concrete pavement joint, especially in the Midwest where freeze-thaw and de-icing is a major issue. Those concrete pavement joints can often be a limiting factor in the service life of those pavements, and providing a more durable joint would lead to significantly reduced repair and rehabilitation costs, downtime of pavements, and really anything associated with that premature deterioration of such an important asset. So in order to understand how this technology works, I first need to set the stage so that you can think differently. If you have experience with penetrating sealers or coating technologies, this may look like that, especially visually when you first put it down, but the way it performs is very different. And understanding how it performs is pretty key in knowing the expectations in terms of what you should see when you put it down and what you should expect over the life of the product of 10 plus years. So as we said, this is a technology that was sponsored by the Indiana Soybean Alliance. It is a soy-based technology, which makes it very sustainable. It's also cost competitive with readily available raw materials. But really, mostly what I'm going to talk about today is the performance of the technology. If it doesn't perform, if it doesn't provide durability to the concrete, then there's absolutely no point to talk about how cost competitive or sustainable it is. And it really performs. It outperforms most any other technology on the market that meets this need. And to tell you how it works, it performs very differently. So typically, if you're using a penetrating sealant or a coating, you would apply that to the surface of concrete. The goal with a technology like that one is to undergo some sort of a chemical reaction that creates a barrier layer between concrete and fluid and things on the surface in the future. So when you create that barrier layer and it's solidified, it's then vulnerable in the future to mechanical abrasion, snow plows, cracking from mechanical loading or anything like that. That can create a gap in that sealant barrier we've created. And then that gap can allow ingress of fluid and ions. And in some cases, the barrier then even limits the ability of the fluid and ions to make its way back out of concrete through evaporation. But with PoreShield, what happens is if we have a dry piece of concrete and we apply it to the surface, it's actually itself absorbed into the pores of the concrete. No chemical reaction takes place. So while it's living in the pores of the concrete, it stays liquid and hydrophobic, which means it's naturally going to want to repel water. The real nice factor of this material or property that allows this to happen is that it has a surface tension that's much lower than water, which means when we put it on the surface of concrete, it's going to infiltrate and penetrate anywhere water can, and in fact, it can go further. It just needs the time to be able to do that. So once we've applied it to concrete, it's absorbed into the pore network. We've got a nice barrier below the surface of a liquid hydrophobic material that's really plugging up the pores. Capillary suction is what's going to bring that in once we put it onto the surface. This means that once we've got a treated area, a certain depth below the surface where our pores are filled with SMEPS, then if a crack would happen through that treated area, that allows air in behind our sealed layer, which would re-engage capillary suction and allow the material to move from those local pores into the damaged area and into the edge of the crack where it will fill the pores there and help to perpetuate that damage from snowballing. So really provides long-term protection. We say the lifespan of a single application is 10 or more years. because this protection is being provided from inside the concrete rather than on the surface where it's vulnerable to things, like I said, like mechanical abrasion. So very long-term protection. You can see in these blocks on the top right, they're standard ASTM 666. These blocks you're seeing pictured here are after 300 cycles, so the conclusion of the test. You can see the two in the middle that were treated with the SMEPS or the PoreShield have no damage to speak of. They look almost exactly the way they did when they went into the beginning of the test in the first cycle, whereas the solvent-based silane or coating product there on the right eventually starts to break down at the surface, which means that it's going to start to track with the untreated concrete because we're not protected beyond that barrier layer. And if we do have some gaps, that fluid can get in and freeze and thaw and then continue to migrate and adjust and repetitively freeze and cause that type of damage. So as I said, the original development of this was for pavement joints. That's where you can see this graphic down here. The idea behind this technology was to alter the school of thought with concrete pavement joints rather than trying to fill them with some sort of a physical divider like hot pour asphalt or a backer rod and self-leveling silicone, where the goal is to keep the water out of the joint. What we've done is go ahead and leave the joint open, protect it with PoreShield or SMEPS so that the pores around the saw cut joint are protected, and then allow the water to flow through the joint and into the drainage channels we've created. This means that we are allowing the water in, but we're not allowing the water to be absorbed into the concrete where it can cause damage. So water can flow through, run off and drain out or evaporate in the way it needs to, but isn't absorbed into the vulnerable joint geometry of that concrete pavement where it can cause damage. The technology works just the same on surfaces. It just, as you see over here, is a penetration down from the surface to where you get a barrier layer and you've disconnected the pore network. You can see this visually by including fluorescent dye into the PoreShield or the SMEPS and then allowing it to be absorbed into a concrete sample. We can then take that sample and break it open and put it under a black light so that the fluorescent dye is activated, and we can see where in the pore network the SMEPS is living. So looking at this photo, it's pretty easy to tell, I think, that if you have this type of a concrete and you've treated it in this manner, then if you apply water ions to the surface, it's very hard for that to be absorbed because you've got a nice deep divider there in your pore network of that liquid hydrophobic protection of SMEPS. So we saw the blocks earlier, but this is the data that actually corresponds to ASTM C666. The two blue lines there at the top are the treated samples you saw in the middle of that picture that's now on the bottom left. The red line you see there is the solvent-based silane, which is the block on the right. As we said, once it gets to 50, somewhere between 50 and 100 cycles, it takes on that damage. And then it starts to track with the untreated concrete sample because the sealant layer on the coating layer on the surface is no longer effective. So what does this mean in terms of the life we would add to concrete pavements, bridge decks, and things like that? The Wisconsin DOT did a study independent of PoreShield, where they just requested some of the material to compare alongside of some other technologies they use for pavement joint sealing. They determined that if you're using fly ash in your mixture, so you're using your mixture design process in order to help to mitigate these issues by refining your pore network and creating something that's more durable, even in those cases, treating with PoreShield topically after the fact is going to provide a 5.4 times multiplier on service life versus no treatment. If you're not using fly ash to mitigate these issues, that number goes up to 9 times multiplier on the service life of your concrete versus not treating. So a significant benefit, a significant advantage for something that is only going to cost a fraction of 1% of the project cost. So that really addresses the topic of fluid absorption. Another major issue in concrete deterioration is ionic ingress, whether that be through pure absorption or through diffusion from the surface into the pore solution. So by creating that barrier in the pore network, we really help to limit that type of diffusion from the surface into the concrete itself. So in that same Wisconsin DOT study, they evaluated reduction in chloride ion concentration with all of these technologies, and PoreShield was the highest performing of all of them. When we look for the first ½ an inch below the surface, PoreShield reduced the chloride ion concentration by 38%, the highest of any of the products they tested. And then the deeper we go, the more that advantage is further. So when we look at the second ½ inch down from a ½ inch to 1 inch in depth, that chloride ion reduction goes up over 60%, which is almost 3 times the next closest product. The deeper we go, the more advantage we're going to see. I would also add that this study was done on a 1-year time frame. And as I mentioned before, the real advantage is the longevity of PoreShield being in the pores rather than on the surface where it's not as vulnerable. means that this advantage would only continue to further as we expanded this time frame out, especially to 5, 6, up to 10 years. Another way we can really show the performance of PoreShield is to look at cross sections and at samples that have experienced some extreme deterioration. So these samples have gone through ASTM 672, but we've actually modified it to make it much more aggressive. This is 10 weeks of daily freeze thaw, so that's 70 cycles. The typical ASTM standard is for 25 cycles. So the photos you're looking at here are essentially the same as running the standard scaling test 3 times back to back to back. And you can really see here in the untreated samples, the surface is extremely rough. You have lots of aggregate protruding as the cement paste has been removed. Some of the aggregate, in fact, are actually almost completely loose to the point they're about to be pulled out of the sample. And then you can really see the story when you look below the surface. Lots of cracking, subsurface cracking, deep into the sample, really all over the place. So you can imagine as we spread this into further and further cycles and we run this test more and more, each additional cycle is going to allow water and salt to penetrate further and filter through all that cracking and damage deep into the concrete, where you'll have lots of water that's going to freeze and expand, and then also allowing the ions to get deep into the pore network because they have free path all the way down inches into the concrete before they even need to be absorbed. Whereas when we look at the treated sample, this is a very aggressive test again, so there's minor damage on the surface from that ice bifurcating and peeling away small pieces of the cement paste over time. But when we look below the sample, you can see really that great protection that the SMEPS is offering because there's no cracking to speak of. That means that with the next cycle, when we get water and salt on the surface, that material is going to be held right at the surface rather than given the ability to flush through the existing damage and really snowball and perpetuate that damage until something is going to need to be taken out of service or otherwise rehabilitated. So we've taken our experience from Purdue in the laboratory and we've tested that in the field. This is actually a really interesting field trial that we did. It was the first one we'd done with this technology, SMEPS, and it was on Pavement Joints. This is Highway US 231 in Indiana. It's a pretty heavily trafficked commuter highway from Purdue University to Indianapolis. The really interesting thing about this test is that this pavement was 13 years old at the time of application. So we're taking something that had experienced over a decade of de-icing practices and Midwest freeze thaw cycles, and we're trying to arrest that deterioration and hold it in place to buy as much service life as we can out of that concrete pavement. So the photos you can see here are 10 years after that application. So now the pavement is 23 years old. In our treated section there on the left with the SMEPS, all the joint faces are even and parallel. In fact, you can even see a few pieces of the old residual sealant that we had removed in order to do this trial. That goes to speak to how intact those joint faces are, versus our untreated section where the joint is starting to really widen and open up as the cement paste of those joint faces is crumbling away and aggregate are protruding. We would expect that that deterioration is going to continue and that joint's going to widen up until it gets to the point where you're going to hear ba-bump, ba-bump, ba-bump as you drive down the highway. So that's the exact type of deterioration that this initial research project was seeking to prevent. And as you can see here, 10 years on, it's still doing a fantastic job of keeping those concrete pavements intact. The picture on the right there is the rod and self-leveling silicone, the old method we used to use where we're trying to keep the fluid out of the joint. You can see that that is no longer bonded to the joint. In some locations, it will have spaghettied out and gotten pulled completely out by traffic. In other locations, it will have debonded and fallen into the joint, which means that water and salt can get behind it. And now that rod and silicone is limiting the exposure of sun and wind. So it's actually making it hard for that water in de-icing salt and everything to make its way back out of the joint and kind of forcing the absorption to take place. We are also members of the AASHTO TSP2 group. Specifically, we've been identified for the Innovative Technology Demonstration Field Program. As part of this program, we'll be doing 3 applications to showcase the breadth of applications of PoreShield. The first one is a pavement joint treatment with Indiana DOT on I-65. The next one is a bridge deck treatment we're doing with Buchanan County, Iowa. And then the third one will be a vertical surface treatment that we're doing with Monroe County, Indiana. So in each of these projects, we'll be taking cores prior to treatment, we'll be taking cores immediately after treatment, and then we'll be taking cores at the 1, 2, and 3 year marks. Those cores will go to an independent lab where they will be tested for fluid absorption as well as chloride concentration. The results of that will go to an independent consultant. In the case of our projects, Dr. Haddock and Pat Connor from Purdue University and the Indiana LTAP program have been chosen as the consultants. So they will be on site for each application to gather contractor feedback and take photos. And then they will also receive the results from the laboratory and write an independent report, which will be submitted to AASHTO for approval and then pushed out to all the member organizations once it's approved. So the goal is to demonstrate not only how easy this technology is to apply, but how it is extremely effective through the long term in all types of concrete, no matter the density or whether it's a horizontal or vertical surface. So as we said, the origination of this technology was to provide more durable highway pavement joints. But since then, we've done plenty of treatments on surfaces, whether that be bridge decks or sidewalks, driveways, and patios. We've also been successfully implemented into mortar patch material, both as an admixture and as a topical treatment over those patches once they've been placed. We've been used with a major precast user in a utility company that their goal there is to protect their fluid being contained in concrete or water containment areas. And the idea is the same as what we're talking about with chloride ion and preventing chloride ion ingress, only it's in the other direction. They'd like to keep the calcium concentration in the water to a minimum. So they don't want calcium leaching from the concrete into the water and affecting the ionic concentration and pH balance of the water. So as I said, also sidewalks, driveways, and patios, thousands of do-it-yourself projects at this point, but also major universities like Notre Dame and Purdue University. Very effective treatment, especially in places where you're going to be de-icing for foot traffic regularly and providing durability to that type of concrete, making sure that sidewalks are safe for passage, not uneven and rocky and rough, but also aesthetically pleasing for the long term there in those types of places. Another application would be animal barns. We've had a lot of applications on hog slats in particular, where it's a very aggressive and corrosive environment for the concrete on top of heavy mechanical loading and abrasion. They've had great success in extending the durability of those types of materials. Additionally, we've had applications in salt storage units and retaining walls. So salt storage units in particular, if we have a building where we're going to be just storing piles of salt and the walls are made of concrete, you can imagine it's about as aggressive of an environment as you could place concrete. So adding a material like this topically onto those walls goes a long way in terms of adding durability and reducing the need to constantly be going back and repairing and patching those walls as they're going to be deteriorated by the salt. So really delaying that process, holding the salt out of the concrete and adding years to the life of that type of a structure. Since then, we've actually moved also into structural concrete, where not only are we trying to keep the concrete intact, aesthetically pleasing and from deteriorating, but we're trying to protect steel inside the concrete by keeping chloride ions at the surface and not allowing them to penetrate down into the concrete where they can initiate that type of a corrosion of rebar. Again, new uses for SMEPS continue to grow. I would say it's every couple of weeks at this point, we're finding a novel application and sending out product to give it a shot. One topic or one program we've done here in Indiana was called the Infrastructure Preservation Program. We did this last summer with Indiana counties in order to offer them the opportunity to treat some concrete that would have likely otherwise gone unprotected. So the way this program was put together was that these counties were offered the opportunity to submit to us concrete that they would like to treat. If the project was approved, they would go either through their contractors or with their own workforce. They would purchase the product, they would apply it to a bridge or a sidewalk, then they would send us pictures of the material being applied, as well as their invoices for their material purchase cost. And then they would, at the end of the day, be reimbursed for the material cost of that application. So allow them to see how quick and easy it is for them to apply, how their in-house crews have no problem doing it. Actually, this crew that you can see in this photo here, or this GIF, went out on Monday morning hoping to treat 6 bridges. They thought it would take them a few days, hoping to have it all done within a week. I was out there with them to help support, and they actually, by lunch on the very first day, had all 6 of them done. So goes to show how fast and easy it is, even with a crew that doesn't have any experience using the technology in the past. In this case, they were able to put a tote on the back of a truck, attach a pump and 3 wand sprayers, and then basically able to treat that bridge about as fast as those 3 gentlemen could walk. That bridge you're seeing in the top photo there, 23,000 square feet, and they were able to treat it in less than an hour, 50 minutes from end to end. So we talked about how high performing this material is. There's really 2 aspects to it in terms of preventing fluid ingress, water, freezing water, and any of the ions it brings in, but also preventing ionic ingress in the form of diffusion, ions that would be existing on the surface of concrete that has pore solution and diffusing into that pore solution. So those two mechanisms really help to stop the vast majority of deterioration in concrete that occurs prematurely, really inhibiting things like spalling, scaling, efflorescence, obviously freeze-thaw damage, keeping those chlorides at the surface so that your rebar is not corroding and you're not getting that sort of swelling and expansive damage from that type of corrosion. And then also some other topics that we haven't addressed here, but we have peer review papers coming out in the next few months that show this material is a strong protectant against things like calcium oxychloride formation or other forms of chemical deterioration, as well as arresting things like alkali silica reaction. So treating the pore network with SMEPS prevents the water from coming in to feed that reaction, and also prevents silica in the aggregate from being able to dissociate and diffuse through pore solution to be available all throughout the pore network, and holds it in place if it does exist in the pore network. Some other advantages: it's very easy to clean up with soap and water, and it works on all densities of concrete, as I said, whether that is a vertical or horizontal surface. If you're treating a vertical surface, capillary suction will pull it into the pores, and then the forces required to move it are so strong that even gravity is negligible. Once you've applied it on a vertical surface, it's going to live in those pores for 10 plus years, and you never have to worry about that coming out. The only reason we even apply or recommend that retreatment at 10 years is because if we have a treated area through our pore network, we have some cracking or damage in the pore network, whether it's from loading or snowplows or abrasion, and the material has moved to accommodate that damage, we want to backfill the volume of the pore network and the new damage to make sure we perpetually have protection. So we talked a lot about the performance attributes of PoreShield. As I mentioned at the beginning, it's also safe and sustainable. It is a soy-derived technology. It's actually USDA certified to be 93% bio-based, and it's on the mandatory federal purchasing list. This means that projects or programs that have federal dollars on them should be considering products from the mandatory federal purchasing list as a priority over any other technologies. This is adding value not only to infrastructure in terms of making things last a lot longer, but it's adding value to ag commodities like soy, creating jobs in rural communities. Extending the service life of our infrastructure also reduces the carbon footprint by reducing the need for repair and replacement cement and cement products, so lowering the CO2 expense associated with that type of manufacture. This technology is also itself a low VOC product. 43.3 grams per liter puts it well below all national standards, including the most stringent, which would be the California Air Resource Board and the Southern California Air Quality Management Division. Both of those limitations are set at 100 grams per liter, so this material is below half of even those limitations. I mentioned before, easily cleaned with soap and water, so no need for petroleum-based solvents for cleanup. That includes people and equipment. And then non-toxic profile, keeping workers safe. No PPE is required. Typically, we would recommend that you would use gloves and goggles, but that's the type of thing we would recommend with any non-water material. It's safe for the environment, so land, air, and water. There's no concern for overspray into waterways or land, and it has a TSCA-listed hazard-free SDS. So thanks for taking the time to let me discuss PoreShield with you. Before I leave you, I'd like to give you a chance to hear some of the contractor feedback. So I'm going to play a short video now of some of the contractors that actually applied through this program and the experiences that they had with using PoreShield.
It's actually gone a lot better than we had expected. As far as the time frame for being able to apply the product, I came in today originally hoping to get half of the bridges done. Here we are at 10:30 this morning, and we're well on our way to being able to complete all 6 bridges today. This went very, very well. Probably the biggest surprise I had is just the environmental friendliness of it. Like I said, again, not having to worry about inhaling noxious chemicals all day for the guys has been huge, or dealing with burns or anything of that nature. So the fact that we can come out here, if we get a little on us and get a little bit of vapor, it's not harmful, that's a huge benefit. Yeah, I feel like this would, it's going to be actually a long-term positive for the budget. It's going to make the infrastructure last longer, but it justifies its cost just alone with the fact that we can go, when we're applying for grants, which is an annual process, and showing that we are maintaining our current assets we have a plan in place. The investment in this product is going to more than see its return on investment through that process.
Hello, my name is Carl Anderson. I am Superintendent of Orange County Highway Department. This bridge was built in 1978. It is approximately a 155-foot span bridge. It is a single span bridge. This bridge is actually located very close to the largest agricultural business that we have in the community, and there is a tremendous amount of truck traffic. Approximately 50 to 60 semis a day cross this bridge, sometimes even more, definitely more during harvest times. Just to be honest with you, I got an email and didn't really know a whole lot about the product, but I know that we are very lacking in our preservation, and I'm always looking for ways that we could come up with some money to do some preservation. So I definitely went after this grant and was very glad to get it, and I thought if we could start here, maybe this could turn into something bigger for the county and we could keep on with our preservation projects. We came out and we had a portable pressure washer on a trailer. It took us approximately a day and a half of pressure washing. We got in every little nook and cranny, got it as clean as we could possibly get it, let it dry. And then when we came back for the application, it was a nice, sunny, hot, dry day, and we just did 1/2 of the bridge at a time. One of the main things I like about it is it's environmentally friendly. We can spray this over the creeks, over the waterways, whether it's a dry bed, active water running underneath the bridge, and feel good about if there was, a drip or two to get down into the waterways. It's safe, it's not gonna hurt anything. With the price that it is and for the minimal labor that's involved and the time that I believe we're going to gain on our bridge decks in the future, I think it's going to be a minimal cost and a high reward at the end. It was very fast, very easy, and I actually did it myself. So I was out here and I did the application on it, and I had a couple other guys with me as well, but I was hands-on involved in the application, and I'm here to tell you it's easy. Anybody could do it.
My name is Zack Smith. I'm the Noble County engineer. I oversee Noble County's infrastructure asset management program, which includes over 800 miles of roadway and 62 bridges. When we were looking at starting a preservation program, we were focused on bridges that were 15 years or newer, that still were in good condition, still had a lot of life left, and our goal was to preserve that life as long as possible. We were really starting at ground zero when it came to concrete protection. Historically, we've had a lot of bridges that were older, and there was no preservation plan in place. So as we looked to the future, we looked at a lot of our newer structures and how to preserve them long term. Obviously, we want a proven product that's been studied, but we also want a product that we can install ourselves without any special licensure. So when we were looking at products, PoreShield met both of our criteria. When we were originally looking at a budget for this year's startup program, we had $50,000. We were thinking that might have been on the low end. We ended up doing 13 structures for under $10,000. So that was the big thing that stood out to me as far as starting a program and having that be a surprise.
I thank you for your time today. I hope that both my information on this topic and this technology was good and informative for you, as well as the feedback you just heard from these contractors. If you should have any questions about this technology, or if you would like to try some in the future, you can visit PoreShield.com to find plenty more information, and my contact information is available here and on these slides. So please feel free to reach out to me with any questions you might have. Thank you.